All right, let's go ahead and go over these. All right, so again, tomorrow you have a quiz, 10 of these in 10 minutes. It's only going to be sine and cosine tomorrow, even though I'm going to show you how to get the other 4 today. Only over sine and cosine tomorrow. Okay, so first thing that I would do is look at the reference angle. Okay, so when I see sine of pi 6, I'm thinking over here to myself, pi 6. Every pi 6 reference angle is going to have an ordered pair of square root of 3/2, 1/2, plus or minus. Do you agree? You have to at least know that pretty darn quickly. Doesn't matter if it's 1 pi 6 like this, or it could be 5 pi 6, or it could be 7 pi 6, or 11 pi 6, okay? They're all going to be that ordered pair. So if it's 1 pi 6, I know I'm in quadrant 1, where they're both positive. Now I want the sine. Of course, sine is the y value. So sine y, it's 1/2. And that's the answer. I'll just put 1/2 underneath there. Yeah, that's it. Done. Yeah, you could do that, all right? That took less than a minute. And that was thinking through it. Okay, so now on part B. Cosine of 2 pi thirds. I don't look at the cosine yet. I don't even look at the 2 yet. What I'm hearing is blah, 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 pi thirds. And so in my mind, I'm thinking pi thirds as an ordered pair of 1/2 square root of 3/2. Because remember, pi thirds is 60 degrees. So it's closer to 90 degrees. This means your triangle is narrower than it is tall. So the y value is bigger than the x value. Square root of 3 is bigger than 1. People get confused with those. So just flat out memorize it or understand what you're doing. Now I'm thinking 2 pi thirds. 2 thirds is just less than 1, isn't it? Just less than 1. So I'm over here in quadrant 2, just less than pi. I'm in quadrant 2. And in quadrant 2, to get there, I have to go left and up. Left and up means negative, positive. Okay, so now that I have my ordered pair and I have my signs, you want the cosine? Okay, cosine x doesn't work. But, you know, it's the other one besides sine y. So it's got to be negative 1/2. Okay? Negative 1/2. Good? Yes, yes. Cosine's the x. Alphabetical order. Cosine, sine. C comes before S. In the alphabet song, like X comes before Y. All right. Now it's pi fourths. That's how I read it. We'll go pi fourths. So anything that's something pi fourths is square root of 2/2, square root of 2/2. The boring one, as I say. And now it's 7 pi fourths. I'm like, oh, 7 is 1 less than twice 4. Or you just realize that 7 is going to be over here in quadrant 4. In quadrant 4, to get there, I have to go right and down, right and down, right and down. That's positive then negative, positive then negative. Now that I got the signs of both my ordered pairs, you want the sine? Okay, that's the y. And you're done. Negative square root of 2 over 2. Boom, done. It's not bad at all. We're going to get all of these done in probably less than 30 seconds. Total, right? All right, now 3 pi halves. You're like, ooh, 3 pi halves. Ooh, where's that? So you got to memorize your quadrantal angles, right? 0, pi halves, pi, 3 pi halves, and then 2 pi. So 3 pi halves is down here. What's the ordered pair down there? 0, negative 1, right? You don't go left to right. You just go straight down. 0, negative 1. Hey, you have both your cosine and your sine value. What did I want? The cosine, so it's 0. If I had put sine, that would have been negative 1. But it was cosine, so I put 0. It's the x-coordinate. And there you go. There's all 4 answers. You can do 10 of those tomorrow in 10 minutes, right? Yeah, heck yeah. It's only going to be sine and cosine tomorrow from any angle on the unit circle. Notice the variety there. We have a pi 6, a pi thirds, a pi fourths, and a quadrantal angle. Okay? So there you go. That's tomorrow. We're tests on Wednesday. Your 2 clues problem will be your free response. And then on Thursday, we're going to test 10 minutes, 10 of these, but instead of all just sine and cosine, it'll be all 6 trig functions. Okay? All right, so before we get to those, let's finish up the 2 clues problems. Okay? Because there's one more variety. Jumping back up. Remember, we kind of jumped down and jumped back up. So we're on example 6. I think you'll be pleased with example 6 because it's really not a 2 clues problem. It's a 1 clue problem, right? And if you can solve a mystery in 1 clue, that usually solves a little bit faster than if you have 2 clues, right? Or 2 clues. So if the terminal side of some angle theta on example 6 passes through the point negative 4, 3, Find the simplified exact values of all 6 trig functions of theta. All right, the terminal side passes through the point negative 4, 3. We can draw that. Okay, so here's your y-axis, there's your x-axis. Where's the point negative 4, 3? 1, 2, 3, 4, 1, 2, 3. There it is, negative 4, 3. So the terminal ray, it says, passes through there, something like that. So the angle theta that gets us over there is here. How am I going to list all 6 trig functions? Well, I need a reference triangle, so I need to drop a perp from some point on that terminal ray. Remember, it doesn't matter from which point I drop the perp, because the scale factor will divide out. Hello, Stacy. From which point would you suggest I drop my perp? The point it gave me, negative 4, 3. Now look how easy this is. First of all, there is no doubt that I terminate in quadrant 2. Would you see that? So there's not a Pooh's Clues problem. It's not like I have to find an overlapping quadrant from 2 given ratios or the signs of 2 ratios. It gives me an ordered pair. That puts me directly into one quadrant. So now I drop a perp from that point, and now I also have 2 of the 3 side lengths, don't I? Negative 4, so the length is 4, but to the left, and then positive 3 up. And now all I got to do is find the hypotenuse. You can use the Pythagorean Theorem, or you can realize that this is a special right triangle because it's a Pythagorean triple. Anyone know what the hypotenuse is? 5, yeah. It's your old 3, 4, 5 right triangle. Now, if you need to come off to the side and say parentheses 3 squared plus parentheses 4 squared equals r squared, that's fine. You're going to get r squared equals 16 plus 9, which is 25. We always consider plus or minus, but in this case, the radius is always positive, so it's 5. And, of course, once you have all 3 sides of a right triangle in the correct quadrant with the correct signs labeled on your x and y, you have all 6 trig ratios, right? All right, so let's list them. We'll do sine of theta first. It's y over r, so that's 3 over 5. Cosine of theta, it's x over r, so that's negative 4/5. And notice tangent of theta is y over r. That is 3 over negative 4, so negative 3/4. What's the slope of that line? What's the slope of the terminal ray? Negative, well, it's rise over run. So if you go from the blue point at negative 4, 3 to the origin, you're going to go down 3, right 4. That's negative 3 over positive 4. That's a negative 3/4. Yeah. The tangent ratio ends up being the slope of your terminal ray. That's kind of an interesting observation. Cool beans. All right. Makes a nice cool bean soup, I guess. All right. Cosecant of theta is r over y. That's 5 over 3. That's the reciprocal of sine. The reciprocal of cosine is secant. So that's r over x. That's negative 5/4. And remember, when we say it's negative 5/4, we know it's negative because it's the 4 that's negative. And then cosecant of theta is the cotangent of theta is the reciprocal of tangent, and it's negative 4/3. And that's not the slope. Okay. All right. So there they are. We pair them up as inverses. So we could also find the angle too. We should probably do that, even though the instructions don't say it. Go ahead with your calculator in degrees. We've been working this with degrees. Go ahead and find the angle in degrees. Remember, this is part of the pre-response. Just whenever you have 5 minutes outside of class. Yeah, you're just filling in the unit circle. Come on, calculator, dude. There it is. Which trig ratio are you going to use? Does it really matter? Remember, I'd probably stay away from the other three since you don't have the button, but you know all of these are right. Probably the safest one to use is tangent because you were given the x and y value. So I'll go ahead and use that. Whatever. So theta equals, if I'm going to use that, I'm showing inverse tangent, which remember is not the reciprocal of tangent. How would you compute cotangent? Well, we'll do that later. One thing at a time. All right, so mode, I'm in degrees, so that's good. I'm going to hit second tangent. You got to check your mode first. Second tangent of -3 divided by 4. And it's going to give me an angle. It's probably not going to be the one I want. It gives me, bless you, -36.86. Okay. That gives me a quadrant 4 angle, -30, blah, blah, blah. Tangent's negative in quadrant 4. I see that. But tangent's also negative over here. So remember, I can use the calculator's answer to find the reference angle. And the reference angle of that is the reference angle of the one I want. So what would be the reference angle of the calculator's answer? That's a negative acute angle, right? So the reference angle, just multiply it by -1. And you have the positive version. So there's the reference angle of the calculator's answer. Theta equals 36.869. And we're going to call that theta ref. So I'm going to write that down. Sometimes you find the angle first, sometimes you find the reference angle first. Calculator may give you the answer you want. But if not, find its reference angle. There it is. And now go back to my picture. To get to my angle, I need to stop that much short of 180. So this is what I just found. 180 is right here. So for me, the angle is going to be, I'll go ahead and write it out. So theta should be 180 degrees now minus the reference angle. And remember, we're using the live answer. Don't ever, ever, ever use a truncated number, because if you're wrong in the third decimal, I'm going to count it wrong. So 180 minus the answer, second negative. And there it is. Now I'm going to store that as alpha A. Okay, so 143.130. 143.130. Now let's verify. We know we could verify these by hitting sine of that angle, cosine of the angle, but how would we evaluate cosecant, secant, and cotangent at this angle to verify these ratios? Well, here's how. Okay? Cosecant, remember, is 1 divided by sine of theta. Secant is the same as 1 divided by cosine of theta, and cotangent is 1 divided by tangent of theta. So you're going to have to use the sine, cosine, tangent button, which is why you don't need the cosecant, secant, cotangent button. So let's verify. I stored my angle theta as 143, yes? So let's type in 1 divided by sine of A. We should get 5/3, okay? 1 divided by sine of alpha A. It's the same angle. You don't flip the angle. It's 1 over sine of the same angle. Math, enter, enter. Do we get 5/3? Yes. Good. All right. Let's verify the other one. How am I going to verify secant of theta? Well, I'm going to type it in as 1 divided by cosine of the same theta. I should get -1.25. Let's try it. 1 divided by cosine of 143 point blah, 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 which again is alpha A. Store your angle, -1.25. Perfect. Math, enter, enter. And we're getting -5/4. And for what it's worth, we'll do the last one. To verify the cotangent is -4/3. I'm going to type it in as 1 divided by tangent of the same angle, 143 point blah, blah, blah. And I should get -1.4, right? -1.4. Let's try it. 1 divided by tangent of 143, which I stored as alpha A, 1.4. Yep, -1.4 actually, which is correct. Why is that forest? Tree. Yeah, see? So that's another name for a repeating decimal 3, forest. A lot of trees. Okay, lots of trees. If you want to hit math, enter, -4/3. Okay, there you go. So, you should be able to finish that part of your homework now, right? Now, to verify the others, you just type in the button. But to verify the reciprocals, you don't hit second sign, right? That's to find angles. You hit 1 divided by sine, and then it's the exact same angle. You don't flip the angle. 1 divided by sine, 1 divided by secant. Okay. Questions on that? We've already talked about a quadrantal angle. That's one that terminates on the x and y axis. So let's go ahead and jump down to the unit circle again. How can I use the unit circle to then find all of these 6 trig functions if I only have the sine and cosine values? Great question. I will show you. And you could probably infer from what we just did how you can find some of them. All right? Here's how. These are called trigonometric identities. These are your first identities. An identity is an equation that's true for all values in the domain, meaning they're mathematical synonyms. You could replace one with the other without any loss of generality. Okay? So here it is. Tangent of theta in general is sine over cosine. Right? What's the definition of tangent of theta? Sine over cosine, because it is y over x, yes? And on the unit circle, what's the y coordinate? Sine y. And on the unit circle, what's the x coordinate? Cosine. Now, what if we're off the unit circle? What if the radius is not 1? The unit circle is the only one that has r equals 1. Well, it still works. Watch this. Because sine of theta in general is y divided by r, cosine of theta in general is x divided by r. If you stay change flip, you get y over r times r over x. What happens with your radius? It divides out and you get y over x every single time. So regardless of the size of the triangle, tangent is always sine over cosine, which on the unit circle is always y over x. So if you know the definition of tangent in terms of x, y, and r, you know how to find tangent from the unit circle because x is cosine and y is sine. Sweet. How do we find cotangent? Well, 2 ways. If tangent is sine over cosine, cotangent is the reciprocal, cosine over sine. Well, what's the definition of cotangent in terms of x, y, and r? X over y. X over y. And if the radius is not 1, if we happen to be not on the unit circle, again, the radius divides out very similarly to what's above. So there you go. That's how you find tangent and cotangent from the unit circle. Tangent's y over x, cotangent's x over y. How are we going to find the secant then? These are the ones we just did. Secant is the reciprocal of what? Cosine. Don't we know the cosine? We do. So it's 1 over x. All you got to do is flip the x coordinate. Flip the x coordinate on the unit circle. Sweet. And how do you think we're going to find cosecant? It's the reciprocal of what? Sine. So that's 1 over y. So all you got to do is flip the y coordinate. Reciprocate it. Reciprocate it. For instance, right here, look at the y coordinate. It's pi 6. What's sine of pi 6? 1/2. Guess what cosecant of pi 6 is? 2 over 1, which of course is 2. Yeah, that's what I mean by flip it. Reciprocate it. Reciprocate it. What is cosine of pi 6? Square root of 3/2. Guess what the secant of pi 6 is? Well, you're going to flip it to get 2 over the square root of 3. But then guess what you have to do? Rationalize it. So you get 2 square root of 3 over 3. So guess what secant of pi 6 is? 2 square root of 3 over 3. You have the number. All you got to do is flip it and rationalize it. Those are actually going to be pretty easy because you're kind of staring at the answer. You're just staring at the answer upside down for the secant and cosecant. Let's try this. What is tangent of pi 6? Well, it's y over x, isn't it? So it's 1/2 over the square root of 3/2. What's going to happen with those 2's, the denominators? They're going to not cancel out. They're going to divide out. And you're going to be left with 1 over the square root of 3. Good, which when you rationalize is the square root of 3 over 3. So that's tangent of pi 6. Now, here's what's cool. This is why we rationalized all the denominators when we put them on the unit circle. When you're doing a tangent, you don't even have to worry about the 2's when you pull it off the unit circle because they're going to divide out. So for tangent, just do y over x. 1 over the square root of 3 and then rationalize it. Your 2's are going to be gone. Guess what the cotangent of pi 6 is? The 2's are going to divide out. It's x over y. It's square root of 3 over 1, which is the square root of 3. See how easy it is? With a little bit of practice, you got it. Let's try this one. What is tangent of pi 4? Well, the 2's are going to divide out all the way around the unit circle. So it's y over x. It's 1. Square root of 2 over square root of 2. What's cotangent of pi 4? Well, the 2's are going to divide out. Now it's x over y. Still 1. Whenever you have tangent or cotangent of any pi 4 angle, that's simplified, it's always going to be either 1 or -1. Don't that easy. Yeah, raise both hands, Caitlin. Rejoice. Woo! Okay. How about secant of pi 4? Which one are we flipping for secant? The x or y? No. X. It's the reciprocal of cosine. Well, what do you get when you flip square root of 2 over 2? Well, let's do it together. You get 2 over the square root of 2, yes? Which when you rationalize by multiplying by the square root of 2 over the square root of 2, you get 2 square root of 2 over 2. But what happens with that? The 2's divide out and you're left with square root of 2. Guess what the reciprocal of the square root of 2 over 2 is? Square root of 2. Because remember, before we rationalized it, the square root of 2 over 2 was 1 over the square root of 2. Okay? So when we take our quiz on Thursday, and I ask you for the reciprocal of the square root of 2 over 2, you're going to have to tell me square root of 2. Okay? What would the, that would be secant. What would the cosecant of pi 4 be? Well, now you're flipping the y value, which is also what? Square root of 2. Let's go to the next angle. What would be, let's do that. What would be secant of pi 3? Well, what's cosine of pi 3? 1/2. So what's secant of pi 3? Flip 1/2 and get 2. Yeah. Well, what's cosecant of pi 3? Well, let's see. What is sine of pi 3? Square root of 3 over 2. Yeah. So cosecant, you flip it. What do you get when you flip square root of 3 over 2? You get 2 over the square root of 3, which when you rationalize it is 2 square root of 3/3. Yeah. What is the cotangent of pi 3? Well, for cotangent and tangent, your 2's are always going to divide out. Those are the only 2 that are in terms of x and y. So what's x over y? It's 1 over the square root of 3, which when you rationalize it is square root of 3 over 3. You could probably do this in your head. All right, what would be the tangent of pi 3? Well, your 2's are going to divide out. It's y over x. Square root of 3 over 1 is square root of 3. And there it is. You're done. Boom. So there's all 6 of them for pi 3. We didn't write down the sine and cosine, but that's how you find it. So here's what I would suggest. Notice how it's easy if you see the ordered pair. On your quiz, when you take it, especially in the beginning, if you need to write down, when it's something pi 3, if you need to write down, something pi 3, write down 1/2 square root of 3/2, and then get the sign, like if it were 4 pi 3. 4/3 is just bigger than 1, so that's quadrant 3, where they're both negative. Write it down. Now you're ready to answer the question very easily. For instance, what would the cosecant of 4 pi thirds be? Well, you're going to flip the y value, which is 2 over the negative square root of 3. And then when you rationalize it, you get negative 2 square root of 3 over 3. And there's your answer. Takes you way less than a minute. That's how I put it together. Think about the unit, the reference angle, blah, 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 blah. Figure out the quadrant, get the signs. And when you're staring at the actual ordered pair at the correct sign, it's just a matter, do you want the x, do you want the y? Do you want the reciprocal of x, do you want the reciprocal of y? Do you want the y divided by the x, or do you want the x divided by the y? That's it. Those are the 6 questions you ask yourself. Okay? Let's look at the quadrantal angle. Let's do one that's kind of funky. Let's do pi. Not funky, but you know, pi, negative 1, 0. Of course, let's just write them all out here. What's cosine of pi? This could be on your quiz tomorrow. Cosine pi. Negative 1. Good. What's sine of pi? 0, right? Sine y, sine y. Right? Remember, sine measures the height. Sine height. And on the x-axis, we've squashed the height to nothing. Okay? So now, what would be the secant? Well, remember, secant is the reciprocal of the x-coordinate. What's the reciprocal of negative 1? No. Remember, negative 1 is the same as negative 1 over 1, which when you flip it is 1 over negative 1, which still equals negative 1. Yeah. 1 and negative 1 are their own reciprocals. The reciprocal of negative 1 is still negative 1. The reciprocal of 1 is also 1. What would be the cosecant of theta? Oh, it's the reciprocal of 0. What's the reciprocal of 0? Oh, let's see. 0 is the same as 0 over 1, yes? Flip it, you get 1 over 0. Wah, 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 wah. All year long, when we get non-zero over 0, that's DNE because it's some type of infinity. Non-zero 0 is DNE because it's some type of infinity. DNE is what you put. Why is that? Look in terms of the definition. Cosecant is R over Y. What's the Y value there? 0. Are we allowed to divide by 0? No. Okay. What would be the tangent of theta? Well, for the quadrantal angle, you don't have to worry about the 2's dividing out. It's just y over x. What's 0 divided by negative 1? Good. 0 in the numerators are fine. That's 0. What's cotangent? I'm putting theta, but I should be putting pi the whole time. It's the same thing. Let's put pi. Secant of pi, cosecant of pi, tangent of pi. What's cotangent of pi? X over y? Negative 1 over 0. Wah, 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 wah. It's also DNE because it's some type of infinity. So DNE would work fine. What's the definition of cotangent? Well, it's x over y. There's only 2 trig functions that have y in the denominator. So when y is 0, they're undefined. Guess what the only 2 trig functions with y in the denominator are? Cotangent and cosecant. So when y is 0, they're undefined. The reciprocal of 0 is what? What's the reciprocal of 0? Nope. DNE. It's infinity. The reciprocal of 0 is infinity, plus or minus. So you can say DNE. What's the reciprocal of negative 1? Negative 1. What's the reciprocal of 1? 1. What's the reciprocal of the square root of 2 over 2? Square root of 2. Good. Just the square root of 2. Good. Good. What's the reciprocal of 1/2? 2. What's the reciprocal of square root of 3/2? 2 square root of 3/3. Good. 2 square root of 3/3. What's the reciprocal of negative square root of 3/2? Negative 2 square root of 3 over 3. Good. Good. Good, good, good. What's the reciprocal of 1? 1. What's the reciprocal of 0? DNE. Good. And the reciprocal of square root of 2 over 2 is what? Just the square root of 2. Okay, good. Goody gumdrops. Okay, so that right there concludes this section. Your quiz tomorrow is 10 and 10, just sine and cosine. Where can we go to practice? Corpy's World. Da-na-na-na-na-na, na-na-na-na, Corpy's World. Na-na-na-na, na-na-na-na, Corpy's World. Isn't that like an Elmo? Here's using the unit circle practice. For 5.3, using the unit circle practice. Hey, your quiz tomorrow is going to be like set 1. But I say you could do those in 6 minutes. Tomorrow I'll give you 10 minutes. Why not today? I give you 5 minutes. See if you could do those. On your marks, download. I'll create a new note. I'll import it. No excise tax. You're welcome. It's all free. So download 5.3b from Corpy's World. Your quiz tomorrow is going to look almost identical to set 1, except they might be in a different arrangement with different angles. But it's going to be just sine and cosine, and it's going to be any angle from the unit circle, and you'll have 10 minutes. So why don't I give you 5 minutes to do those, and then we'll go over them, okay? Okay. Ready? Okay. Oh, my gosh. There goes the amygdalas. Pyong, pyong. Now are we ready? No? Okay. No? Maybe? I'll give you... Okay. Download. At least you know where to go to practice. Hey, guess where else you can go to practice? This is kind of cool. If you go to the Quizlet app and you type in KORPI' space WORLD, there will be this kind of practice with flashcard style. There's some that say just sine and cosine, and there's some that say all trig functions. So if you're like the flashcard type of person, there you go. Quizlet, unit circle, Corpy's ' World. There's some that are just sine and cosine. I would recommend going there and practicing. No, anybody can go. 5 minutes. Okay. Sorry. You're practicing these at home as well, if you're watching the video. Or this is where you get up and go to the bathroom. This quiz is tomorrow. You will not have your unit circle out in front of you tomorrow when we do this, by the way. Just take the candy cane. See, it's Christmas in February. Make sure you get the correct SIGN sign on your ratio, because if you have the wrong sign, then it's wrong, even if it's the right magnitude. See, that's halfway now. That's 2.5 minutes. So 5 minutes is a lot of time to do 10 questions. Huh? What's that? That was only 2.5 minutes. Yeah, I know, right? Tomorrow you'll have 10. So tomorrow when I call time on this one, you'll be at the halfway point. You'll have time to like read a novel afterwards and write a book report on it. Good morning. Happy Monday. Writing the ordered pair is not a bad idea. In fact, when I do these, I still write the ordered pair, but I write it in my head. I visualize it. You all have, of course, less experience, so writing it out in front of you is not a bad thing to do. The rest of the page is, the same stuff, except notice starting on set 2, it includes all 6 trig functions. And then the time ratchets down. You have fewer and fewer minutes to do it. The fastest we're going to do it is 3 minutes. All six trig functions, 10 and 3. And then, of course, 10 of them, 3 minutes. And then we're going to, at the very end, have the ghost pepper challenge where you do 10 of them in 1 minute. And then that grade, it's just for fun, but if that grade ends up being higher than one of your other ones, we'll replace it. It's the ghost pepper chili challenge. 10 of them in 1 minute. Can you do them in 6 seconds a piece? Sure. After a while of practice, right? What's 9 times 5? It's 45. It's just the same thing. What's cosine of 7 pi 6? It's negative square root of 3 halves. Huh? Yeah, I mean, it's a fun one. Okay, 2 seconds, 1 second, stop. That's 5. See, that's 5. So tomorrow, that'll be halfway, and you'll be like, dang, what do I do with all this extra time? I could have slept in. Could have hit snooze one more time, all this extra time on this quiz. All right, let's see how you did. So again, here's how I quickly do them. Sine of 5 pi 6, immediately I think pi 6, and I'm thinking I'm thinking square root of 3 halves, 1 half. Now 5 is just less than 6. 5 is just less than 6. So it's just less than pi. It puts me in quadrant 2. To get to quadrant 2, I go left and up. So there's my ordered pair. Sine y, 1 half. Ta-done. How long did that take? And I didn't hear anybody yelling out and going, I during the quiz, so that's good. If it helped you to get that in your head, that's fine. That's where you're keeping it. All right, number 2, blah, 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 pi 6. So again, I'm seeing square root of 3 halves, 1 half. 7 is just bigger than 6. 7 is just bigger than 6, so it's bigger than 1 pi. It puts me just into quadrant 3. To get to quadrant 3, I have to go left and down, so they're both negative. Cosine is not the so it's the x, so it's the negative square root of 3 halves, done. Boom. Now, if you do this regularly, if you do the rest of this, you get that very quickly. You can go through all of that rigmarole very, very quickly. Rigmarole, by the way, is the word of the day on dictionary.com. Number 3. Sine of 3 pi fourths, blah, 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 pi fourths. So I'm seeing square root of 2 halves, square root of 2 halves. 3 is just less than 4, so it's just less than 1. That just puts me in quadrant 2. That's to get to quadrant 2, it's left and up, so it's negative positive. Sine y, positive square root of 2 halves. Done. Okay, see that? Sweet. Number 4, blah, 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 pi 6. That's square root of 3 halves, 1 half. Ooh, 11. I spot a 11 as of quadrant 4. Sometimes you just know that, right? Ooh, that's quadrant 4. 11 is 1 less than twice 6, okay? So that's quadrant 4. To get to quadrant 4, I go right and down, so it's positive and negative. Cosine, that's x. There you go, square root of 3 halves. This all takes place very quickly in your head, okay? All right? I mean, about as much time About as much time as the guy who's in charge of the 151 cameras on the Super Bowl last night after a play has to pick a camera for the instant replay. I mean, it's that fast. He has 151 cameras to choose from, and he has them all memorized by names like Chuck, Charlie, George, Fred, right? And that's what he does. He looks at them all and he goes, all right, Fred! And so that Fred plays their instant replay. He likes that angle best. You do this that fast because you practice, right? Yeah, I saw that on CBS Sunday morning, yesterday morning. It's a good show. It's like positive news stories if you want to watch news stories with a happy ending. Pi fourths. That's square root of 2 halves, square root of 2 halves. 5 is just bigger than 4, so that's just bigger than 1. That's in quadrant 3. To get there, I go left and down. That's negative, negative. Sine y. There you go. Done. Man, it's so easy, so fast. Okay? That's how I do it. Do you want me to kind of quit doing that and just kind of do it now? Okay, good. Are you getting annoyed? All right, 4 pi thirds. Okay, it's here. It's there. 4 is bigger than 3, so it's quadrant 3, so it's negative, negative, cosine negative a half. Boom, done. Done, done. All right, blah, 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 pi fourths again. Square root of 2 halves. Square root of 2 halves. And after a while, you don't have to write that down. You're just thinking about it. 5 is bigger than 4 just by 1, so it's in quadrant 3. Negative, negative, cosine is the negative. Done. Oh, yeah. Number 8, blah, 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 pi thirds. That's the 1 half square root of 3 halves. 2 is less than 3, so it puts me less than 1, less than pi. I'm in quadrant 2. To get there, I go left and up. So it's negative positive. Sine y. Ooh, that one was, see, I held back on that one. Sine y. Number 9, blah, 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 pi 6. So that's square root of 3 halves. 1 half. 5 is less than 6 by 1, so that's quadrant 2. So that's negative positive. Cosine. There you go, negative square root of 3 halves. Fast, 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 right? Like you're at Jimmy John's stuff, right? Boom, boom, boom. Sine of 3, 3 pi halves. Ding, 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 ding. I spy a quadrantal angle. So when they're not on the interior, when they're not pi 6, pi fourths, pi thirds, but they're either like pi 0 or pi halves, it's quadrantal. So you just write it down that 0, negative 1, sine is negative 1. Boom. Done. There's all 10. You get 100. Yeah. Boom. Sweet. And now you know the unit circle. Okay? See, it makes perfect sense. Right? And then I holster my eye pencil. It's used for anything that involves rotation, trig, geometry, engineering, math, orienteering, math engineering, good one. What's the other one? Architecture. What's another one? Surveying, yeah. Teachers, yeah. Anytime you want to, like, you're shooting an elevation across a river, and you want to measure the width of the but you can't, you don't have a tape measure to get across the river, so you shoot a point across the river, and then you shoot another point across the river that's a certain distance away that you can measure on land. You can easily, and then you figure out you can easily figure out the width of the river without actually getting wet. Yeah, or tall things, right? You can measure the height of, like, the Eiffel Tower from the ground. Isn't that cool? All you need is one of these guys, see? One of these guys? Because you just shoot angles of elevation, and this thing will give you your angle of elevation by looking at the straw. Who knew that you can measure the height of the Eiffel Tower from the ground, right? No way, right? There's some idiot that doesn't know trig. He's trying to find a tape measure that's long enough, right? And then he's going to crawl to the top and let the tape measure dangle down. He's like, what you reading down there? And you're just like, dude, you don't even have to get a tape measure or go on the Eiffel Tower. You can measure the height from the ground using trig. All right. Have a wonderful, great rest of your Monday. Remember, Rosa Parks, just say no. I'm riding in the front.